Hello, how are y'all? Happy Big Tuesday. Today, we're going to be covering homework 6, part 2, and we're going to be making a couple of functions. It shouldn't be too terrible, so let's get started. So first thing off, I'm going to knit and see where we left off. Okay, so part 2 starts with identifying trip regions. The terminal, to station ID and from station ID columns in the data list station data frame and data list trip data frame have 2 or 3 character codes followed by a hyphen and a numeric. Have a 2 or 3 character code followed by a hyphen and numeric. Okay, these character codes convey the broad geographic regions of the stations. Things like CBD means Central Business District, PS means Pioneer Square, ID means International District, and so on. Write a function called region extract that can extract these region codes by taking a character vector as input and returning another character vector as output that just has these initial character codes. For example, if I run region extract x equals, and this vector with 2 elements here, CBD-11 and ID-01, it should give me an output of a character vector with the first entry CBD and second entry ID. So it looks like this. Note, if you cannot get this working and need to move on with your life, try writing your function to just take the first 2 characters using the string sub function and use that. We're going to be able to get the first ones working, so we don't have to move on with our lives. Okay, so first things first, let's see what these columns are looking like. We have data list station data and data list trip data. What I did to have these things in my environment is I clicked this little down arrow here that says run all chunks above, such that I would have these things in my environment. So now I can say data list double extract station data and pipe that to the glimpse function to see what we're working with. So the question is telling us we're going to be interested in things like this terminal column here that says BT-01 and BT-03. BT is presumably Belltown. Yeah, 2nd Ave and Vine Street, 3rd and Broad. That sounds like Belltown to me. And then the other one was data list trip data. If we look at the glimpse of that, what do we get? So like same smell from station ID CBD 06 Central Business District and 2 station ID PS 04 Pioneer Square. Okay, so we've got that. We want to make a function called region extract that can extract these regions. Okay, so the first thing I'm going to do then is, let's see, I'm going to make another chunk. And then I'm going to make an example that we can practice with while we're trying to write this function. So I'm just going to write a thing called example vector and assign it those 2 examples. So CBD-11 and ID-01. Okay, so that example vector is just a character vector with 2 elements, those 2 strings. And then what we wanted to do is extract just these parts, CBD and ID. So we're going to be using the stringer library in order to do this. There are a lot of ways that we could be doing this. I think I might have like led a little bit by saying extract these region codes. So I'm going to use the string extract function to see if that can make the basis of what we're going to be doing. So we're going to string extract our example vector, but how are we going to get it to say remove just those character codes? My plan is to write a regex, a regular expression. And I find that when I want to write a regular expression, if I can describe what I want to happen, that will typically be the way that my regular expression gets written. So for me, right now, I would say I want the letters before the hyphen. So there are other ways you could be saying something like that to get this answer. Like, for instance, you could say, I want to remove the things starting with the hyphen. Or I want to match 3 or 2 letters at the beginning of this phrase, that kind of thing. But for me, I'm a fan of, I'd like to get the letters before the hyphen. And so the way I would do that is now in quotes, I'm going to write this regular expression, and I would say in square brackets, capital A through Z, and then asterisk. And what this piece of code is doing is it's saying match letters as many times as you can until there's no more letters. And then if you want to be a little bit redundant, you can say look only in the beginning. That should be fine. Yeah. So now that we know that this works, on our example, we can write our function to be more pliable. So we could say region extract will be the name of our function. We will assign to it the function. And that function will take the argument x. I think that's what the instructions asks us to do. Let me check. Yeah, region extract x equals some vector. Okay, so our function is going to take the argument x, and then in curly brackets, we're going to make the body of our function. And we are going to say string extract x, comma, and then our regular expression here. If we want to be really explicit about it, we can say string equals x and pattern equals our regular expression. And we can run that. Now we can see if our region extract function still works on our example vector. And it does. Okay, is that tracking? Is that making sense for everybody? Okay. Yes, cool. Then the next thing I'm going to do is I think I'm going to get rid of this. Do I need to do an eval equals true? I'm going to do that. I'm going to say eval equals true. And I think that you need to do that in order to make functions populate when they get knit. So let's knit and see if that's true. Okay, so we did these glimpses, yada, yada. We made this example vector. We saw that string extract and this regular expression could get our stuff to work. And then we made the region extract function and tried it in our example vector and it worked. But is that all we need to do here? Should output a character vector. This does output a character vector. We can tell because CBD and ID are in quotes. Okay, and the next thing we need to do is say then on data list station data and data list trip data, make new columns called terminal region, to station region, and from station region using the region extract function. Okay. So let's get started with that, so in station data, we need to take the terminal column and make that terminal region. Okay. So something like data list, double square brackets, station data, and then mutate terminal underscore region equals our region extract function and the terminal column. So let's see what that looks like. Actually, let's then pipe it into Glimpse so that we can see what it looks like really quickly. Okay. So we took the station data and then we made this new column called terminal region using our cool new function on the terminal column. And then we looked at our whole data frame and all of its contents. And we saw that our terminal column had values like BT01, and our terminal region column has values like BT, BT, CBD, so on. Cool. So I feel like that worked. So I'm going to get rid of that last pipe and glimpse, and then assign this to our station data frame to override it to make sure that we keep our terminal region column. Yeah, and we're going to do the same thing for our trip data column, but for two of the columns. Check which names of those. From station ID and to station ID. So this comes called in and mutate. What does the question want us to name these things? To station region and from station region. So to station region equals region extract to station ID. I'm going to say comma here, hit enter, say from station region equals region extract from station ID. Okay, I'm going to pipe that into a glimpse so that we can see it. And so now things like our from station ID's first value was CBD-06. Our from station region's first value is just CBD. Our to station ID's column, our first value is PS04, and our to station region is now just PS. Great. And so now I'm going to get rid of this glimpse call on that last pipe, and then assign our data list trip data to our data list trip data in order to save those two columns. Okay, is that all making sense? Cool. Are we cool to move on? I don't have like a time limit, so. All right. Then I'm gonna knit and we're gonna see what the next instructions are. Okay, let's see. Identifying rainy days. So the events column in the data list weather data frame mentions if there was rain, thunderstorms, fog, etc. On some days, you can see multiple weather events. Add a column to this data frame called rain that takes the value rain if there was rain and no rain otherwise. You'll need to use some string parsing since rain is not always at the beginning of the string. The function string detect may be useful here, but again, if you're running short on time, just look for rain at the beginning, using string sub as a working but imperfect approach, then convert rain variable to a factor. Okay. So we are going to check out this weather data frame by going data list, double square brackets, weather data, and then we'll use glimpse to see what we got here. So it says events, rain, 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 rain. Let's say type to tail and then glimpse and see if there are other things. So sometimes our events column has an NA and sometimes it's fog, comma, rain. And when the reason we want to use string detect is for a value like this, where it was fog in the morning and rain in the afternoon, and they said fog, comma, rain for the events of that day. Okay. So we are going to add a column to this data frame called rain that takes the value rain if there was rain and no rain otherwise. So it sounds like a classic if else case. And we want to have our if else based on whether or not rain is somewhere in the string of our event column. So we're going to say mutate in order to make this new column that is going to be called rain to be equal to if else. We're going to string detect. So recall that string detect returns a true or false. So we can use it to be our logical expression for our yes and no's in our if else. So string detect the events column, and then the word rain. And then we could say comma. I'm going to hit enter here for like legibility. Yeah. Comma, rain, comma, enter, no rain. Okay. And then I'm going to do the same thing. I'm going to look at the bottom again in order to check if we're getting the right stuff. So here, we had that fog and rain value for one of the rows has correctly returned rain. However, this NA returns as an NA because we can't test for if something's an NA this way. So there's a couple ways we could approach this. I'm trying to think about which one I'd be most happy with. How about I just show you two ways to do it? So one way you could do it is by manipulating your rain column by overriding it by saying rain, if else, or no. Rain, yeah, rain if else is dot NA rain, return no rain. Otherwise, the rain column. And so what this is doing is two if else's in a row. The first one says, look in the events column. If rain is present in any of the character string there, say rain, otherwise no rain. But this won't change your NAs. So then we go back and say, make this new rain column that's based on the logical expression, is there an NA in the rain column? If so, we're going to say that it's no rain. Otherwise, just give me whatever the value is in that rain column. So that's one way to approach this problem. I'll show you that it worked here. So like our first thing was an NA, and now it just says no rain. This is, of course, an assumption that we're making about our data, but it's one I'm pretty comfortable making. Another way you could approach this is, if you don't like doing this, making two rain columns here, one thing you could do is say like this. You could mutate rain equals case when. And then we would make a few different cases for when to handle all three of these situations. So the first one would be case when is.NA events return no rain. And then the second one would be string detect events rain, return rain, and then everything else return no rain. And these are equivalent expressions, and I don't know. I'd say I tend to do this one. This one makes more sense to me. Often while I'm writing things up. But sometimes it's nice to just do it all in one line like this. But let me show you that this works by sending tail and then glimpse. And so down here, our NA has returned no rain. Our fog rain value has returned just rain, and our just rain value has returned rain. So they are doing the same thing. I'm going to just overwrite our weather data with this one, but you only need to pick one. So I'd say just choose either one because they're equivalent. In order to emphasize that you only need to pick one, since I tend to think that some people just kind of put me on mute and then scroll to each of the questions, I'm going to delete this one to affirm to those kinds of people that you only need to pick one. Okay, so let's knit and see what we got next. Oh my goodness, I didn't convert to factor. Okay, you give me a second. We don't need that. Yeah, we could still just say rain equals factor, and that'll work. Anyways, let's knit. Okay, so we've gone and done this using string detect. Next, we're going to merge rainy weather and trips. So you have a bike station region information now and rainy weather information. Make a new data frame called trips weather that joins the data list trip data with the data list weather data by the trip start date, so that the rain column is added to the trip level data. Just the rain column, please, none of the rest of the weather info. You may need to do some date manipulation and extraction as seen in the week 5 slides to get a date variable from the start time column that you can use in merging. I think that we already handled that. If you followed these same instructions last week, then you'll recall up here that our start time column is already in POSIX CT, yada, yada, yada. So it should not be a problem. We'll see. Okay. So merging these trip data and weather data and just the rain column of the weather data. So I'm hearing the word merge. I'm thinking there's a join. Let's see. We want to join by the date. So let's see what dates that we have. So I'm going to say data list trip data and then glimpse. Again, we had this start time, but it's in date time. We might need to do some manipulation knowing that it's in date time. And then our weather data, we're going to do the same thing and pipe that into glimpse so that we can see. Yeah, this date is just the date. It does not include the time because it's just today. These are the things that happened in the weather. Okay, that's good to know. Let's see here. We only want the rain column. Okay. So first thing that we need to deal with is that the trips start time data that we want to use is in date time. So we are going to take our data list trip data and then mutate. And we'll call this column, we should call it the same thing as in the weather data. So they just have capital D date. So we're just going to make this one capital D date to make joining on the same column like really clear and obvious. So our trip data date is going to be equal to, there's a couple ways to do this. I'd say the fastest way would be we could just coerce it into being a date as dot date start time. And let's look at that so I can show you what I mean. So now we have this date column that it says the first value is October 13th, 2014. And it is a date column rather than a date time column, like up here that says October 13th, 2014 at 10:31 in the morning. Okay. So I would say that's probably the fastest way to do it. It's just coerce it. Once you've already turned it into POSIX CT time, it's really easy to just make it into a date that way. So we'll do that. And then we want to join in our weather data. So we could say, I'm thinking about what kind of join that we need. We probably want to inner join so that we can just drop all the columns that don't have a, or drop all the rows that don't have anything in them to get rid of the NAs that don't match. So let's say inner join. And then in this inner join data, we're going, or inner join function. So what's happening is it's going to pipe in our trip data already to the first argument. And our first argument is going to be the like left-hand side data frame. So we're going to be saying to our, if you want to make it explicit, we can say x equals dot, and then y equals data list weather data, so that I can make sure that we're all on the same page here about what's happening. So we're piping this information that we've just manipulated to the left-hand side of our join by using this dot notation, then saying comma, and then our right-hand side, this y equals, is going to be our weather data, but we really only want the rain column. So we're going to say select date and rain. Okay. And while we don't have to, the only matching columns are going to be the date column. We can also supply to the by argument date. And this should run just fine. So now we can type that into Glimpse to see how that goes. So we have things that were already in our trip data, things like the start time and the trip duration, the who rode the bike, an annual member who's male and born in 1960. But now we also have our factor column, rain, that has information like whether or not it rained that day. And seeing as it's October, right when this data starts, it was raining that day. We don't have to really, we don't have to check. Okay. Yeah, so let's then assign this to a column. I believe it was going to be called trip weather. Trips weather. So we're going to assign this transformation here to trips weather like this. Run that. Does that make sense? Does this order of steps make sense of how we got here? Yes.
I'm saying rain doesn't exist, but I know it exists.
I see. So let's see. When you run like something like this,
Yeah.
rain is in there. Gotcha, gotcha, gotcha. Of course. But yeah, we're happy with this order of steps and how it's related to our instructions and all that. Cool. So this is the last question then. I'm going to knit so that we can see the instructions for our last question. And those say, make a summarizing and plotting function. Now for the grand finale, write a function called daily rain rides that takes as input a region code, so things like CBD and UW, and a direction that indicates whether we are taking a trip from or to a particular region. And inside the function does the following. It filters the data to trips that come from stations with that region code or went to stations with that region code, depending on the values of direction and region code that are provided to the function. For example, if I say region code equals BT for Belltown and direction equals from, then I want to keep the rows from trips whose from station region is equal to BT. Then make a data frame called temp.df, short for temporary data frame, with one row per day, counting how many trips were in that particular region code supplied to the function and going the direction supplied to the function. This should have columns for the trip starting date, how many trips there were that day, and whether there was rain or not that day. You'll need to use group by and summarize in order to accomplish this. Then use the temporary DF to make a ggplot scatterplot using the geom point layer with trip starting date on the horizontal axis, number of trips on the vertical axis, and points colored black for days with no rain, and deep sky blue for days with rain. Make sure the legend is clear and that the x-axis is easy to understand without being overly labeled. You can control this with the scale x date layer option. The title of the plot should be customized to say which region code is being shown and which direction is being analyzed. Things like daily rides going to South Lake Union using the pace 0 function. Feel free to use whatever theming you like on the plot and other tweaks to make it look great. Return the ggplot object with all its layers. So I have gone ahead and made a skeleton for this function. Fill in the code as needed and remember to set eval equals true in the chunk after you've written the function. Then test your function by making 3 plots using the daily rain rides function, trying out different values of the region code and direction to show it works. Whew. Okay, let's get started. Okay. So let's get the first thing out of the way first. Inside the function does the following. Filters the data to trips that come from stations with that region code or went to stations with that region code, depending on the values of direction and region code. Okay. So we already know that our function is going to take the arguments, region code and direction. So I think since we have two options here for direction, the best way to handle it would be to just make an if function then else statement. Like so, we would say if the function, so if direction equals 2, and then it's going to do some stuff. And then we're going to say else on the same line as the ender of our if. I don't want to mess up the way an else works here. Oh, that's you say else if direction equals from, and then we're going to do some stuff down here. So this is already getting us situated to answer this first question. So if the direction equals 2, it's going to do some stuff here. Else, if direction equals from, it's going to do some stuff here. Okay. So what stuff is it going to do? It's going to filter the data to the trips that come from stations with that region code or went to stations with that region code. Okay. So let's say it's going to go to stations with that region code. We're going to say trips weather, and then filter to station region is going to equal the one that's supplied to the function. So equals region code. So that's going to, I'm going to add some enters or some returns here to clarify what's going on. So here's if the direction equals 2, then our trips weather data is going to be filtered for the station region that's going to the one that's specified by the function. So this region code is going to go down here in our function. And when they specify the direction, it's going to determine whether or not it's going to use this one or the next one we're about to write. So this one's going to say trips weather, and then filter from station region equals region. Okay. Is that making sense so far? Okay, so the next thing that we need to do is make sure that when these things occur, that they're going to be saved so that we can make a plot out of them later. So that's where our temp df is going to come in. So we're going to assign to temp df on these things that are occurring. So in the case where someone specifies 2, our temp df is going to take on the to station region information in rows. And in the event that someone says from, it's going to take on the from station region information in rows. Okay. The next thing that's going to happen, so after these two things complete, we could, if we wanted to, say like, if else anything else happens that's not to or from, send us a message. I don't think we need to do that right now for this assignment, but know that we could, and there's really good examples in the slides. So let's say now we want our temp df to group by, right? So we've covered this. Filters the data to the trips. For example, if I say region code, Belltown, and direction from, then I only want to keep the rows from from station region. Okay, so we've done that. Now we're going to make a data frame called tempdf with 1 row per day, counting how many trips were in the region code going that direction that's been specified to our function. This should have columns for trips starting date, how many trips were that day, and whether there was rain or not that day. You'll need to use group by and summarize. Well, you don't have to use group by and summarize. The trips were in region code and direction. So tempdf is already going to have our region code and direction because it got filtered during those if else things. So now we could, if we wanted, just overwrite those and then group by our starting date and then count how many trips were that day and whether or not there was rain that day. Okay, so what we can do is after this curly bracket from the if from, we're going to assign to our tempdf the tempdf. So what's happening here is I'm saying this tempdf is going to be created during these filters, and then we're going to assign to it, we're going to override it by saying, and then let's see. There's a couple ways to do this. The way I tend to do it personally is I would say count the combinations of date and rain that are in that temporary data frame. And that's the same as saying group by date, rain, and then summarize trips equals something like this. Or saying just tally here would also be these are all equivalent expressions. So that's why I tend to do the one that just says count date rain because it's faster. And then we're going to use that information to make a ggplot. Yeah, so we'll say, and the data that it's going to take is going to be the tempdf that we've just created right here. So that's going to happen. And it's going to be a scatter plot, if I'm not mistaken. So we did that. Use tempdf to make a ggplot, scatter plot using g on point with trip starting date on the horizontal axis and number of trips on the vertical axis. Okay. We're going to say g on point, and the aesthetics are going to be on the x-axis is going to be the date, and on the y-axis it's going to be lowercase n. And the reason that it's lowercase n is because count will produce the count of these combinations, and it will supply a column name called lowercase n. And we want to color it by if there was rain or not. So this, I think, should run already. So let's try. So if we try daily rain rides and say region code equals BT and direction equals from, could not find ggplot. I see. I have not loaded ggplot in this homework. That makes sense. So I'm going to go back up to my libraries chunk and put ggplot up here. And now I'm going to try this again. Okay, great. So like we've kind of got it. Now we just need to make the plot look nice, but things are working. So these are trips that come from Belltown and go anywhere else. And it looks like there's less rain in the summertime and that there are more trips in the summertime. That's kind of neat. I'm realizing I'm kind of glossing over how you might troubleshoot this. One thing you might want to do, let's say that you're working on this solo dolo, is, so like I'm already well aware about what will happen in an else if of this kind. One thing you could do is just set up a sort of like pet example and then go back and make it modular afterward. So this would be saying something like, you would copy paste this and say our region code is going to equal DT, and that's going to be our temp df. And then we will copy paste this, and we can look at our temp df at each step and see that it just has rain for our x-axis, some information about whether or not it was raining and how many things there were, and then we can make a ggplot out of temp df and practice that way. So one thing that you could do is just sort of like arbitrarily pick, I'm going to do Belltown and it's going to be the 2 option, and check to see if it runs that way in little pieces instead of, I'd say with practice, you'll get some intuition about whether or not something's going to break right at the start. But let's make this ggplot look nice in the meantime. So ggplot, our temp df, geom point on the x-axis is date, on the y-axis is how many trips there were, and it's going to be colored by whether or not it rained that day. Points colored black for days with no rain and deep sky blue for days with rain. So one thing we can do in order to specify what colors are going to be things, we can say scale, color, manual, and we could say values is equal to, and we can say no rain equals black and rain equals sky blue. I know I typed that kind of quick. Does that make sense? That we're going to supply to this, which helps us tell ggplot what we want our colors to be. It's going to be based on what we supplied to the color aesthetics earlier in the ggplot call. And then the values it's going to take are a vector that says whatever values are mapped inside of this column are going to be equal to these colors that we specify. And this, and practice again, and ooh, black is no rain, blue is rain. What else does this ggplot or do these instructions want us to do? Make sure the legend is clear and that the x-axis is easy to understand without being overly labeled. Okay, so the legend right now just says rain, no rain, rain. We could just say in our scale color manual call, we'll put a comma and then hit enter. And we could say name equals, I don't know, weather. Sure, that's fine. I feel like this date is pretty intelligible to me already. One thing we might want to do is just get rid of the thing that says date down here, since people know what Jan 2015 means. So we could say scale. No, we could say theme, and then say axis dot title dot x equals element underscore blank. So this is slightly different than saying X lab and then putting nothing in quotes. This will actually make it so that there's nothing that occurs there at all. It won't like allocate space as if there would be an X label there. We probably want our Y label to say something that's not just N. So we could add Y lab and say number of daily rides. And then we could say title And what does this thing do again? Oh, that's right. We need a GG title to do something. The title of plot should be customized to say which region code is shown and which direction is analyzed. So daily rides going to SLU using base here. Okay, so we will say label is equal to paste 0 daily rides, comma, the direction, comma, the region code. Is that right? Region code? Yeah. Okay. So let's try that out. It's case 0, so it could collapse all these. I should add a space. And one way I can do that is to say step, right? That's not how I do it in this. I would add a space here and then add a space and then a comma like this. And that should work. Daily rides from BT. And we had specified BT and from here. So let's say SLU and 2 to see that it works. Now it says daily rides to South Lake Union. Cool. And then I kind of like minimal. And I think we could call that good on this function. So I'm going to get rid of this. And then we're going to change this eval equals to true. And then we're going to go down here and test this out by making a few plots. Something like rain rides. Region code is going to be equal to UW and direction equals 2. And then daily rain rides, region code equals Pioneer Square and direction equals from. And then, I don't know, what are our other rain rides options? We could say, oops, there. I guess we could say, and then what was the name of that column? Region. What was the name of that column? I don't recall. So I'm going to do this. So we can say from station region. And oh goodness, what are these places? Capitol Hill. That's one I recognize. You know, I saw a picture the other day that was just like all the pizza places in Seattle. And Seattle's not a pizza town. We're not like, we don't know anything about pizza. So these are daily rides to UW. These are daily rides from Pioneer Square. And these are daily rides to Capitol Hill. And it looks like lots of people are headed to Capitol Hill relative to other places. That makes sense to me. They didn't have Ballard Pizza Company on there. And I felt really like offended. I was like, I like Ballard Pizza Company better than like Verace or like Pagliacci or whatever. But I think that's it. Let's knit and see. Okay, so we made this big old function and This is to UW. This is from Pioneer Square. And this is to Capitol Hill. And that's all. Thank you all so much. This is the last lab. I will not be doing a lab for the homework 7. Unless y'all really want me to, I'd be happy to do it, but I was not planning on it. Thank you all so much.